Now that we can use the j prime factors verb to find the prime factors of an integer, let's take a look at how we would apply it in the case of Catalan n equals 5. We start with our Catalan formula, which for n equals 5 becomes factorial 10 divided by all of factorial 5 times 6. We then reduce the list to prime factors. The prime factors in factorial 10, namely 2, 3, 5, and 7, remain unchanged. But the composites, 4, 6, 8, 9, and 10, are a different story. 4 becomes 2 times 2, 6 becomes 3 times 2, 8 becomes 2 times 2 times 2, 9 becomes 3 times 3, and 10 becomes 5 times 2. Our original equation becomes this long list of factors. I'll admit that it looks like quite a jumble, but let's see what happens when we clean it up by reordering. Then we can simplify further by combining the factors of the denominator. And finally, we can use exponents to reveal the result in a more meaningful way. Now division is done by subtraction of exponents, which simplifies to 7 times 3 times 2 times 1, giving us the result 42, which is the Catalan number for n equals 5. So instead of multiplying out the original equation, we took the prime factors, subtracted exponents, and came up with 7 times 3 times 2 times 1. This is how logarithms and prime factors can make the Catalan calculation more efficient and keep us from overloading the capacity of our computer. The next lesson is how we construct the actual J program that does all of this work.